Hey everyone, this is Baylor, and in this hopefully quick video we're going to practice a code kata. And the real purpose of a code kata is two things. One, so that you can practice the best practices, and which is good because the more you practice writing good code, the better you'll be whenever you get into a crunch time situation where you don't have time to really focus and think through how you're going to solve problems. You'll just have it kind of ingrained into your system. It's also a really good way to learn a new programming language or a new framework or new whatever it is, because it just gives you something to just kind of build over and over again, and you can kind of see how it applies to different languages or whatever. So for this particular example, we're going to build a little library that converts an integer to a Roman numeral. And so I've gone ahead and started this project a little bit. I've gone ahead and got our first test passing, which just confirms that if we give our class a 1, that we get back an I. And you can already see the implementation code is very simple here, and it is perhaps the fastest on the market today. What we want to do is flesh this out a little bit. So the first test that we want to write is that if we give it 2, then we get 2 I's. And when we do this, is it going to work? No, it does not. You can see we have 1 failed, and near the bottom of the screen it shows that we received I, we expected 2 I's. So to make this pass, all we need to do is just add repeat number. And now when we run this, you can see that it passes, because that works. And so now we can go ahead and commit, because we want to commit often, and say add working Roman numerals for 1 and 2. That's probably too long for a commit message, but I don't really care. I'm already breaking the rule of a good code kata, but I think it's acceptable in this particular setting. So one thing I am noticing pretty quickly out of the bat is that we are duplicating the structure for our test. And so the first thing that we could do here is we could tell our test runner before each that we want to define the context of the test. And so we could say t.context is equal to a new numerous. And now that allows us to remove this initialization from each of the tests. And so now we can just say t.context. And we'll put that in here as well. And when we run it, we should still pass, and we do. Now, what I'm also interested to do here, though, is we're calling the same method in all these tests. It's very clear to me that we'll probably always do that. And so one thing that we could do here is actually make the context this particular method call. And so I don't necessarily think that's bad. And as you can see, when I run this, it still works. The only thing that really I think concerns me is that this probably leads me to think that it's not necessary to actually initialize this object to call this particular method. Granted, maybe in a larger system that would make sense, because you probably would have a single class with a single method, but we're going to kind of ignore that, and we're just going to say this is really good. But I think this is a very reasonable thing to do as far as writing unit tests, because going back to what I know from Ruby, Ruby has RSpec, and RSpec you have what's called subject, and that is kind of a magical method inside of RSpec that will initialize the current class under test. And so this reminds me of that, and I think it's fine. But it also, we're co-refactoring this, and I think we could take it one step further in that we have this structure here. It looks an awful lot like this structure here. And I think keeping your unit test dry is a good thing to practice as well. Not only implementation code, but unit tests as well. And so I feel like what we can do here is we could write a method like test number, and that's going to take in our number, or an actual, and our expected. And I only want to name it that because as I think about it, it doesn't make sense to say like number and number, so, or n1 and n2, whatever it is. So what I want to do is actually just copy and paste this up here, and we're going to just change this out so that we say that our actual should be our expected. And in here we can actually just change this out for actual and change this out for expected. So now if we rewrite this to take advantage of our test number, you can see that this is going to actually just I think, work. And it does. And what's interesting is if I pull this up, when we actually run this, you can see that it tells us our test name. I thought maybe it doesn't, but regardless, we can still see the actual test. So I think this is good enough for what we're working with. So let's go ahead and do the same thing for this one, and we can just copy this and paste it in right here, and now we have 1 and 2 both being tested. Perfect. Okay, so what do we want to do next? Well, right now I think 3 is a good number since we've already kind of established that this works. And the next number that we'll probably go to is, I'm thinking we'll probably skip 4, only because 4 is an edge case and it kind of breaks the simplicity of what we're doing here, at least with how we've only gotten this far. And so the next number we'll go to is 5, and we'll make that a big V. And so if we run this, you can see that what we're getting is kind of what we expect, where we have 5 i's come back, but really what we want to do is have a V. And so to solve that, really what we can do here is just say if our number equals 5, then what we want to do is return V. And if we run that, you can see that it passes. So now we can commit this, and it looks like I've added a file. And so we're just going to say that we add support for 5, 3, and 5. Perfect. Okay, so now we're ready to move on to the next number, which I think makes sense to be 6. And when we run this, you can see that it just returns 6 i's, and that's because we've hard-coded in that we want to have the number 5 and nothing else. And so the easiest way I can think to fix this is actually to just store off for like a result, and I'll just make an empty string to begin with. And so if our number is equal to 5, what we can do is we can say our result plus equals V, because 5 is V, and what we can do is say result, or number rather, minus equals 5. And I'll make this greater than or equal to. So if our number is 5, we will add 5 to the result and subtract that from our number. Likewise, if our number is 6, we will still add 5 and just still subtract 5. And that allows us to come down here and actually say take our result and append whatever we repeat off of number. And so now we run this, this should pass. And doing it this way, it's pretty simple as far as what it's doing, but it also allows us to move forward so that if we jump ahead and go ahead and do 10 now, it's going to fail because it's going to do like 5 and 5 1, or V and 5 1s. So we can just take this and put it in here, and we're going to do 5 more here, 5 more here, and make this an X. So when we have 10, or a number greater than 10, we're going to append an X to it. And so if we run this, you can see it works. We have 6 passing tests now. And what's interesting is we can actually go up to 15 here. My mistake, we can go to 15, we can go to 17 here, and these are all still going to pass because we're moving in the right direction, or just keep growing forward. So what the problem now is, the unit tests look pretty clean. The problem is our code is starting to look a little duplicated. And so this is where we need to kind of get to where we do perhaps something in a loop, so that we go through our number and we just continually add Roman numerals to a string until we run out of numbers. And so the way I want to do that is I want to define a constant for our map. And so instead of hard coding it inline into the function, we'll say like 1 is equal to I, 5 is equal to V, 10 is equal to X, and then we'll just stop there because that's as far as we've gotten anyways. And so the way I want this to work is that we're going to loop over this number, and I don't know how to do this without just writing the code. So we'll just hop in and just, what I want to do is I want to sort these keys, because as you can see here, when we write this, we start with the highest possible numbers first. We start with 10. If we went to 50, it would be 50 would be here, and then 100 would be here, and then 1,000 would be here. And so we need to do that same thing here, but it makes it makes more sense to me to actually write these in ascending order, where we say 1, 5, and 10, and so on and so forth. So what we need to do is we need to sort these keys backwards, so that, and this will make sense, I think, once we start writing it. But as far as when we're actually pulling these maps, we want to go from large numbers first. So we're going to sort these, and we'll just call them sorted keys. And these are going to equal to our object.keys. And so what this will do is it's going to take all, like, it's going to take 1 and 5 and 10 here. It'll return them back as strings, so we'll go ahead and map those and take that value and push it back into %. So that'll give us back the number equivalent. And then what we can do is we want to sort these, and we'll have x and y, and we want to say where x is less than y. And so that will reverse them. And what we can do real quick is just grab this and hop in a node. And now you can see when we look at sorted keys, we have their numbers and their backwards. And so what we want to do with this is we're going to remove all of this and just return a result. And we're going to say while our number is greater than 0, what we want to do is basically, what we want to do is our number, let's say we start at this one right here, we start at 15. So what we want to do is get the highest number that is below 15, and so in this case it'll be 10. And so the way we can do that is we can actually call this, and I'm just going to say it's a key, even though key is not a great name. We're going to go off of the sorted keys, and we're going to say find, and that gives us back 10, 5, and then 1. And we're going to say where x is less than or equal to our number. And so that gives us back our actual, like, the key, which is the integer value. And so we can say number is minus equal that key. And at the same time, we can get our letter here, and that is going to be equal to map at that particular key value. And so now we can say result plus equals our letter. And if we run this, everything should still pass, and you can see it does. Now, this may just kind of be a little bit hard to read, so I'm just going to take these again and drop them in a node, and maybe visualizing it makes it a little bit easier. So I'm just going to use n, and we're going to say n is equal to 13 here. So if we say sorted keys, as we remember, this is 10, 5, and 1. And so what we can do is if we say find our key, and we use x, where x is less than n, you can see it gives us 10. And that's because we're saying give me the first value. If we did filter here, this might, you can, my mistake. If we do filter here, you can see that returns all the values. Now if we make n equal to 8 or 7, you can see now we only get 5 and 1. And so what we're doing basically is just taking the first value that matches below our current value. And this is a typo here because 5 should return 5 and not 1. And so we've rewritten this now so that we can continuously grow, and all we have to focus on is this map at the top. So I'm going to commit that and just say that we have created a map for ints to numerals. Okay, perfect. So with this in place, I think now we're ready to play with our edge cases. So we have our first edge case where we have 4, and that's equal to IV. And if we run this, we're just going to get 4 i's. And you can see that's what we get. So what we can do, the easiest way to do this is just say that our 4, we treat it just like we would treat 5 or 10. It's just an increment, and it's just about edge case. And so that gives us, that corrects that one. And we can do the same thing here, and so we can have 9 is equal to ix. And I actually ran that one too early. We need to see that fail first. So we'll do 9 is ix. You can see that it fails. And so now I'll put that back in here. We run it again, and it'll pass. So we can say that we add support for 4 and 9. And now I'm going to stop adding numbers here. This pattern just continues on all the way up to 1,000. And so, but what's really, really cool here with this setup, this is kind of getting out of the code kata because it wasn't necessarily intentional if we had written this for the first time for real. But I will say that when I practiced this before, it blew my mind that it worked again. But which is sad, but it does whenever you first write this. I think it's kind of impressive. So I encourage you to, take this if you want to embellish on this and actually implement the entire character set, I guess, of Roman numerals, because it is kind of fun to actually start playing with this, and it's also fun to take an actual Roman numeral converter online and compare your results, because oftentimes when you get into, I can't remember what the max is on Roman numerals, but it's just like, I think it's like close to 2,400, like 2,399, something like that. And that's a very interesting number to actually generate with Roman numerals and actually see this work. So I want to thank you for watching this video. Hope you found it helpful. If you have any questions, feel free to respond and let me ask, and I'll be happy to answer them. If you liked it, like the video and subscribe, because I plan on making more videos more frequently than I have been over these last few years. So thank you for watching, and goodbye.